start what we want to do today, I want you to do something. Click the subscription button, share this video, and so that when you subscribe, whatever video I post, you have access to it. Share it and like it. So, and then I also want to remind you that we have started our physical lectures at Christ Rock Academy, Saple Road at Total Junction. If you are coming from the town, or coming from Ring Road, so after Aji, that is Christ Rock Academy. There is 24 hours light, and the lecture is 5 to 7:30 p.m. There is light everywhere, it's illuminated, the environment is conducive for learning. See you then, and God bless you. In chemistry today, we are going to talk about the topic carbohydrates. 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 When we're talking about carbohydrates, carbohydrates is an organic compound. An organic compound containing carbon, hydrogen, and oxygen atom in the ratio 1 to 2 to 1. Now, if you take a look at this definition, the compound contains carbon, hydrogen, and oxygen, and the ratio is ratio 1 to 2 to 1. If you multiply this one by the same number, 6, what do you have? 1 times 6 is what? 6. 2 times 2 is what? 12. 1 times 6 is what? 6. This is glucose or simple sugar. 6 is H12O6. So that is why we say it contains carbon, hydrogen, and oxygen in the ratio 1 to 2 to 1. You will discover that in this formula, this ratio 2 to 1 for hydrogen and oxygen is the same as H2O, water molecule. And that is why some textbooks of biochemistry define carbohydrate as hydrated carbon compound. Hydrated. Hydrated means water of crystallization is contained. And this is water. So you cannot separate water from carbohydrate. Now, that is that. Now let's go and look at classification of carbohydrates. Classification of carbohydrates. Now, carbohydrates are basically classified based on the following two headings. There are two headings we use to classify carbohydrates. Number one, we have classification based on size. Classification based on solubility in water and taste, based on taste. Then number two, classification based on size. So let's look at the first carbohydrates based on solubility. In water and taste. Two words together. Based on this, carbohydrates are classified into two types, two classes, which are, we have sugars and we have two glycans. What are sugars? Now, based on solubility in water and based on tasteness, taste, we have two types of carbohydrates. We have sugars and we have glycans. What are sugars? Sugars are carbohydrates which dissolve in water and which are also sweet to taste. They can dissolve in water and they are sweet to taste. Examples of sugars are glucose, galactose, then we have fructose, we have sucrose, and so on and so forth. Now, sugars have different ways of classifying them. We have the simple sugar, we have the complex sugar. Simple sugar, and we have the complex sugar. So, sugars are further classified as follows. We have monosaccharides or simple sugars. Then we have oligosaccharides or complex sugars. Don't worry, we are still going to talk about these ones. Many of you are expecting me to say disaccharide. Disaccharide is the first member of oligosaccharide. We are coming to talk about that. So we have this. Then we can still have reducing and non-reducing sugars. We can still have reducing sugars, and we have non-reducing sugars. But we will never get the understanding of this one until we come and talk about classification of carbohydrates based on sizes. So let's leave it there. We are still coming to talk about them later. So let's go to classification. Of carbohydrates based on sizes. Now carbohydrates are classified and the glycans. We have what we call monosaccharide or simple sugars. Then number 2, we have oligosaccharides, which are called complex sugars. And we have glycans. You can see we are repeating what we have said before, which are called polysaccharides. Yes, let's not take them one after the other to talk about them. I think we are through with these parts. Let's talk about the monosaccharide. The monosaccharide or simple sugar. Now, in the field of science, the word mono means one. Mono. So now, monosaccharides now they are the building block unit for oligosaccharides and the polysaccharides. They are the ones that you have to build, just like you have block. You want to build a house, put one block on top of another one to form a wall. That wall is either oligosaccharide or polysaccharide. Then the only single unit, the smallest single unit, is the word the monosaccharide. And that is why we say monosaccharide is the building block unit, the building block smallest unit of an oligosaccharide or polysaccharide molecule. So they are the products of hydrolysis of oligosaccharide and polysaccharide. So they are the products of the hydrolysis. Hydrolysis that some people call digestion. In biology, they call it digestion of the oligosaccharide and the polysaccharide. So I said here, monosaccharides, they are the what? They are the products of the hydrolysis, that is digestion of oligosaccharides and polysaccharides. So the condensation of a number of monosaccharide brings about the formation of a molecule of an oligosaccharide or polysaccharide. You will see that in this our explanation of simple sugar, we have made mention of two terminologies, which are hydrolysis and condensation. Now that takes me to the definition of hydrolysis. What is hydrolysis and what is condensation? Now, hydrolysis. Hydrolysis is the breakdown of a molecule or a giant molecule, breakdown of a molecule of higher molecular mass. Now, the breakdown in the presence of a number of water molecule in order to obtain a number of monomers, of residues of lower molecular mass. So hydrolysis is the breakdown of a molecule. That molecule has a higher molecular mass, and water, it has to take place in the presence of water. That is why they say water is important for digestion. When you want digestion to take place, hydrolysis is digestion in biology. So you need to take in water because hydrolysis involves breakdown of food in the presence of water molecule. And when that molecule is broken down, residues of lower molecular masses are gotten. Then the opposite of it is condensation. Condensation. Now, condensation is the combination. Can you see now? In hydrolysis is the breakdown. An opposite of breakdown is what? Combination. Combination of a number of molecules of lower molecular mass. Now, in the absence of water molecule, in order to obtain a molecule with higher molecular mass. Let me show you an example of what I'm talking about here in the middle board. So I want to take away the middle board now. So I'm leaving here for you to copy and take your time, little time. Can pause the video and copy. Then let's go. Yes, let me show you an example here of what I'm talking about. C12. Okay, let's do it like this. C6H12O6. This is simple sugar. 2 molecules of simple sugar, they combine together. Then okay, let me do this way. Plus another C6H12O6. The combination is condensation, while the reverse reaction is what? Hydrolysis. And don't forget, during hydrolysis, water molecule enters. During condensation, minus H2O. But what is the number of H2O that is going in and coming out? That has to do with. Now, let's look at this. Now, then what is the product? C6 plus 6, C12. 24. O, 6 plus 6 is what? 12. But we want to here, you have C12, H24, O12, right? Now, but take a look at this in the forward reaction. Water molecule H2O is gone out. We want to remove 2 hydrogen from 24. We'll be left with 22. We want to remove 1 oxygen from 12. We'll be left with 11. This is a disaccharide. A disaccharide, which is a member of oligosaccharide. Now, this is another simple sugar. So, in the forward reaction now, water molecule is removed, then you have a disaccharide got in here. So, if this one has to go through the backward reaction, it breaks down, it undergoes hydrolysis. Then water molecules that was taken away will be added here, and you have this separate simple sugar. So, the equation above is a typical example of equation that shows condensation in the forward reaction and hydrolysis in the backward reaction. Now, let's now go and look at classification of simple sugar. Classification of simple sugar. Classification. Or before that, I want to show you, okay, classification of simple sugar. Let's go. Classification of simple sugar or monosaccharide. Now, monosaccharides are classified based on the following 2 headings. Number 1, classification based on number of carbon atoms per molecule. Number of carbon atoms per molecule. Another one is classification based on functional groups. Thank God we just treated functional group. So if you have issue with functional group, go back and look for our videos that we treated functional. It will be about 3 or 4 videos we used to treat functional group. Now let's go. Can you write that? Let me give you some minutes to write that. Yes, I'm back again. I'm taking this part away. Now, let's talk about classification of monosaccharide based on number of carbon atoms per molecule. Now, based on the number of carbon atoms per molecule, carbohydrate monosaccharides are classified as follows. Now, monosaccharides are classified as follows. Number 1, we have triose. Triose. triose sugars. 2, we have tetrose sugars. Tetrose sugars. 3, we have pentose sugars. 4, we have hexose sugars. And so on and so forth. Let's look at this table. Now, monosaccharide, double C. Then, general formula. Don't forget the general formula is CN A2NON. Okay? Then number of carbon. Number of carbon. The first one here is triose. Triose sugar. Triose sugar. If number of number of carbon, which is N. Number of carbon N is what? Is 3. So if I put 3 here, I have C3, H2 times 3, that's 6, O3. Number 2 is tetrose sugar. Tetrose sugar, number of carbon is 4. So we have C4, H8O4. Then number 5 is pentose. Number 3 is pentose sugar. So that is 5, H10O5. If you put the number of carbon is 5. Then the next one, number 4, is hexose sugar. Hexose sugar is C6H12O6. The number of carbon is, this one is the commonest monosaccharides we have. C6H12O6. So that is that. Then I want you to take note of one thing. What I want you to take note of. Notes. Now, the minimum number of carbon atom present in a molecule of monosaccharide is 3. Take notes. You can't have less than 3. That is why the first member is triose with 3 carbon atoms. So if you are not having 2 carbon atoms, it's no longer carbohydrate. That's why in some terms they define monosaccharides as the simplest form of carbohydrate that cannot be hydrolyzed further. So now there can never be a monosaccharide member having less than 3 carbon atoms. Take note, per molecule. So this is why some scholars define monosaccharide as a carbohydrate molecule which cannot be hydrolyzed further without losing the property of being called a carbohydrate. That's an advanced biochemistry definition of monosaccharide. They say that monosaccharide is a what? Is a carbohydrate molecule which cannot be hydrolyzed further without losing the property of being called carbohydrate. So if you break it down further, no problem. It will not have maybe 2 carbon or 1 carbon. At that time, you no longer call it what? Carbohydrate. It's something else. So that is that. Now, we now go and look at classification of monosaccharide based on functional group. Now, based on this, thank God we have done functional group. You can go and watch our previous videos on functional group so that you will not have problem with this explanation. Now, there are 2 classes of monosaccharides based on functional group. These are 1, we have aldoses or aldose sugars, and number 2, we have ketose sugars. Aldose sugars and ketose sugars. So what are aldose sugars? Now, these are monosaccharides. These are monosaccharides with alkanal or aldehyde, which is equal to CHO, functional group, added to a polyhydroxide molecule of the compound. What do I mean by this? These are monosaccharides that have alkanal or aldehyde functional group. Alkanal functional group is CHO group added to the polyhydroxide molecule of that compound. We are going to look at examples later. Now, I want to clear these parts. Now, then what are ketose sugars? These are polyhydroxide molecules with ketone or alkanone functional group, which is a CO group in the molecule of the compound. Now, then let's look at further classification Further classification. Further classification of aldose sugar. Of aldose sugars. Now, aldose sugars are classified as follows. Number one, we have triose